Have you ever wondered why you may feel warmer wearing black clothes instead of white clothes? Or why you can still feel heat radiating off the asphalt at night during the summer? Well, these effects that we feel can be explained by albedo. Albedo is the ratio that describes how much light is reflected off a surface versus how much light is absorbed by a surface. It is represented by light reflected over light absorbed. The level of albedo an object possesses can range from 0 to 1. A black surface has an albedo close to 0, meaning that it will trap heat. In contrast, a white surface will have an albedo closer to 1, which will not trap heat. This is because of how light interacts with these objects. The wavelengths of light are made up of photons, which are the smallest possible particles of light that have essentially zero mass but carry energy. Because a perfectly black object can absorb all wavelengths of light and their photons, including high frequency and energy wavelengths, the amount of heat absorbed increases. These photons are then converted to thermal energy, resulting in heat. In contrast, a perfectly white object reflects all wavelengths of light, so no photons are absorbed and no heat is generated in the object. Albedo is not only useful to show why dogs should wear booties on hot summer days, but also in climate change and global warming research. The albedo of the Earth is about 0.29 because the surface is made of both light and dark surfaces, such as ice or land. However, 71% of the Earth's surface is covered by the ocean, which means the majority of the Earth is darker colored. Research regarding albedo often focuses on ice albedo feedback loops. One example of a positive feedback loop is how the dark Arctic Ocean waters absorb more heat as the light-colored ice melts, and then the surface albedo decreases. However, albedo is not only a planet-wide phenomenon, but one that affects our daily lives. Our buildings are often constructed from concrete, which has an albedo of 0.4, and our roads are paved with asphalt, which has an albedo of 0.1. In cities, these building materials with low albedo trap a lot of heat, causing an effect called the urban heat island. In densely populated areas, such as Phoenix, where I attend school, this can be a huge concern for millions of people. The urban heat island effect can change rainfall patterns, air pollution, flood risks, and water quality. During heat waves, this can be especially dangerous when heat-related illness can be fatal. In conclusion, albedo is an important parameter for understanding both our global energy balance and the effects of temperature in our cities and day-to-day lives. Research regarding albedo can be used to help further understand the complex effects of climate change and mitigate rising global temperatures.